Hi, my name is Mike Morrow, and I'm an automotive technology instructor, and I'm currently teaching part-time at Copper Mountain Community College in Joshua Tree, California. So anyway, I'm doing a demonstration video on a throttle body, electric throttle body. I wanted to just show you on the bench that we can also operate the throttle body. It's not a test that you would, for say, do on the vehicle. This is just a demonstration to show you what type or what kind of signal is needed to operate that throttle body. So, quick history, cars first came out with carburetors, and to control the speed of that car, they had a throttle cable. We eventually started moving electronics. We had we had fuel injection, electronic fuel injection, and then we still used a cable to control the speed of the vehicle through the throttle body. And now most cars today are using electronic or electric throttle bodies, and they're controlled by the computer. There's a sensor on your throttle pedal now, technically a potentiometer, and that's tied into the car's computer, and the computer decides what you're trying to do there with your foot, and you're pushing on it, you want to go fast, and the computer decides whether you can go fast or not, because everything has to be right on the engine and vehicle before it allows the vehicle to accelerate. So then that sends a signal to the electric throttle body, and that signal on most vehicles is a pulse width. It's a pulse of DC voltage, and the width of that pulse is what varies the speed of that motor on that electric throttle body. So let me show you what I got here. Let me get my other camera on here. Okay. Let me get my little recording tool out of the way here. So what I have here is a Ford throttle body. I think it's off a 2004 5.4 V8 engine. Picked it up at a salvage yard somewhere, fairly cheap, like $10 or something. And it's a working unit. So and here you have the throttle position sensor, which we're not going to be testing today, but this is where it's located. This tells the computer where the throttle plate is at. And this is the servo assembly that opens and closes the throttle, and it receives that signal from the computer. So right now I have it hooked up to a 12-volt power supply. Actually, I went ahead and ran 13.9 volts, which is similar to what a car puts out. And I'm also got my Handtech scope, so we can see the actual digital signal and see how that pulse width changes. So right now everything's hooked up. I'm just going to show you, this is the same as what's on the throttle. This little dial here is connected to a potentiometer, which varies resistance, and of course the computer deciphers all that. And with this, it changes the pulse, and you can see I can control that throttle electrically, the same as if it was in my car and the gas pedal. And this device here is actually producing a pulse width, a variable pulse width. As I change this, it'll change the pulse width, and it will open that throttle. Okay, so that's how that works. Let's look at it on the oscilloscope. So right now the oscilloscope is hooked up to this device here, and you can see very minimal pulse width, and you see my voltage there at the lower left of the oscilloscope. I don't know if I told you, but I'm using a Handtech oscilloscope. Again, a very low cost unit, but it's a very good tool. It doesn't do a lot of the things that the $2,000 models cost, but it definitely can handle most basic troubleshooting and more on automotive. And this is their automotive scope, so it has automotive options. So I'm going to show you the same demonstration. I'm going to turn that potentiometer. You see, as that pulse width changes, that throttle opens. You can see the throttle opening on the left of the screen there. You can see my pulse width widening as I'm giving it gas. And that's how that works. The voltage doesn't change, the frequency doesn't change, just the width of that pulse. And so the computer knows when that sees that pulse widening to, well, actually the throttle position sensor knows when it's getting a wider pulse to start opening that, start moving that motor and opening that throttle. So there's electronics inside of here also. That's what this servo, and there's servo controls in here. So there's electronics here, there's electronics, you have your computer in the car, then you have electronics down at the throttle pedal. So all that together is what has your car going down the road. So that pretty much ends my demonstration here. I just wanted my students or anybody who watches the video to be able to see how that pulse width varies, and at the same time as it's varying, it's opening and closing that throttle. So seems simple, actually is fairly simple, but it's all computerization. So but that's how it works. When somebody talks about PWM, pulse width modulation, this is exactly what they're talking about. All right, you guys have a good day.